Part A. Write down the integral of sec squared x with respect to x. Well, I know that the answer to that is tan x plus c, because I know that tan differentiates to give sec squared, so therefore I know that sec squared integrates to give tan. You can look that up in your formula booklets. You are given it. You're told that tan differentiates to sec squared. So from that, you can hopefully figure out that when you integrate sec squared, you'll get tan. Part B, given that y equals cos x over sin x, use the quotient rule to show that dy by dx is minus cos x squared. So if I'm using the quotient rule to differentiate this, I'm going to let my u function be cos x and my v function be sin x. So u dash, when I differentiate cos, I'll get minus sine. V dash, when I differentiate sine, I'll get cos. Now to apply the quotient rule to this, which will be u dash times v. So minus sine x times sine x is minus sine squared x. Then it's minus v dash times u. So cos x times cos x is cos squared x. And all of that gets divided by v squared, which is sine x all squared, so sine squared x. Now I notice on the top that I've got a minus sine squared minus cos squared. So I could factorise that minus outside and just say it's minus sine squared plus cos squared, which is good because I know that that's just 1. So I get minus 1 over sine squared x, which is the same thing. The 1 over sine squared is cosec squared, because cosec is 1 over sine. So I get minus 1 over cosec squared, which is what I needed to show. Right, part C. Prove the identity tan plus cot all squared is sec squared plus cosec squared. So let's start on the left hand side. Tan x plus cot x all squared. Well, expanding those brackets, I'll get tan squared plus 2 times tan x times cot x plus cot squared x. That's me just expanding those brackets. Now tan and cot in the middle there, well, I know that cot is 1 over tan. So this is like saying tan x times 1 over tan x, which would cancel out. So that middle term is just like me saying 2. Right, so I've got tan squared plus 2 plus cot squared. And I'm trying to write this in the form of sec squared plus cosec squared. Well, I know that tan squared is equal to sec squared minus 1. So I can replace the tan squared with sec squared minus 1 plus 2 plus cot squared. Well, I know that cot squared is going to be equal to cosec squared minus 1. And what at this stage here, I notice that I've got a minus 1 plus 2 minus 1. So they all cancel out, and I just get left with sec squared x plus cosec squared x, which is done. That's what we wanted to show. Right, finally, part D, hence. So using what we've just done, finds the integral from 0.5 to 1 of tan x plus cot x squared. Well, considering it says hence, and we've just proved that tan x plus cot x all squared, we've just proved that that's the same thing as sec squared x plus cosec squared x. So I could just integrate that instead, because they're the same thing. Now, that's useful because in part A of the question, I wrote down that sec squared integrates to be tan. So I already know that the first term is going to integrate to be tan. And in the second part of the question, in part B, I showed that cos x over sin x differentiates to be minus cosec squared x. So that's telling me that if I integrated minus cosec squared x, I would get cos x over sin x. This case, though, I'm not integrating minus cosec squared, I'm integrating plus cosec squared. So plus cosec squared would integrate to be minus cos x over sin x. So just by using the information we've been given previously in the question, we've managed to do this integral pretty easily. Now all I'm going to do is substitute my limits in. So tan 1 minus cos 1 over sin 1 minus tan 0.5 minus cos 0.5 over sin 0.5. And I will use my calculator to work this out, because it wants me to give my answer in to two significant figures anyway. So just bear with me, and you can figure this out for yourselves, of course. I'm sure you've got your calculators in front of you. And I'm sure you'll be quicker than I am, because you all love your calculators. Okay, so to two significant figures, I get 2.2, and that's my answer.